Suppose you are building a trading app. Your agent monitors the market, spots an opportunity, and decides to execute a trade. But it needs a compliance officer to approve it first. The agent sends the approval request and waits. Now, what happens if the application crashes while it's waiting? Or what if the compliance officer is out for the day and doesn't respond for 12 hours? What happens to that approval request if, let's say, there is a deployment, an out of memory error, or if the container restarts? In most frameworks right now, it's gone. The state was in the memory and the request disappears. And in production, that's not acceptable. You need approval requests that survive crashes, that can wait hours or days, and that pick up exactly where they left off when a human finally responds. In this video, I'm going to show you an open source library that solves this with just a few lines of code without major changes to your existing framework. It survives process crashes, it waits for days and not just minutes. Let's get into it. Now, here's what we'll cover. We'll use Agentspan and we'll understand what Agentspan is, its architecture, and how a human in the loop exactly works behind the scenes. Then we will briefly cover LangGraph based agent Python script and see how it works without Agentspan. Next, we will see how to integrate Agentspan, and I'll demo the human in the loop. And finally, we will go through some advanced patterns which are beyond just simple approve and reject pattern. A big thanks to Agentspan team for partnering on this video. Agentspan is an open source runtime for AI agents. It's MIT licensed, completely self-hosted, and your data never leaves your infrastructure. It's built by the team behind Netflix Conductor, which is a workflow orchestration engine that Netflix, LinkedIn, and Tesla have run in production for nearly a decade and have handled billions of workflow executions. Now, to understand what Agentspan really does behind the scenes, let's first look at how things work today when you're using frameworks like LangGraph, CrewAI, or OpenAI Agents SDK. Right now, your entire agent pipeline runs inside your Python process. The LLM calls, the tool execution, the agent state, the conversation history, it's all in one process. And when your agent needs a human approval, let's say for a trade, a deployment, or a contract change, that approval state also lives in the same process memory. When your agent decides it needs approval, LangGraph's interrupt function pauses the graph. The state gets saved to something called a checkpointer. And by default, that's memory saver. That particular thread gets blocked. Okay, so the core problem across all of these frameworks is the same. The approval state lives in your process, and the thread gets blocked while waiting for it. If the process crashes because of deployment or out of memory error or container restart, the approval request is gone. The compliance officer eventually clicks approve, but nothing happens. And this is where agent span comes in. Your code still defines the agents and the tools, so nothing changes there, but the orchestration, like which agent runs, what the LLM decided, where we are in the pipeline, and critically, the approval state. All of that moves to a separate agent span server. Your process becomes a worker and it registers your tool functions with the server. The server makes all the calls to LLM providers and it decides which tools to call, then dispatches the tool call requests to your worker. Your worker executes those tools and returns the results back to Agentspan server, where the server persists the result of every completed step in its database. If your Python process or worker dies because of any reason, the server still has the workflow. When your process comes back up, it polls the server to check any pending workflows and pick up the pending work. So none of the completed steps rerun. Now, here's specifically how human in the loop works with this architecture. When your agent calls a tool that has approval underscore required set to true, the server doesn't send it to your worker right away. Instead, it creates what's called a human task, which is a durable workflow step that gets persisted in the server's database. And the execution for that workflow pauses. The server emits a waiting event. Now, that approval request is sitting in the database. It doesn't matter if your Python process crashes and restarts, because that approval request is now on the server. And here's the key part. How does the human actually see and respond to this request? So this is the dashboard I have built in this video. It's a simple fast API app that shows pending approval requests. The compliance officer sees the trade details and can choose to click on approve or reject. When the compliance officer clicks approve, our dashboard sends a request to the agent span server. The server unblocks the human task, dispatches the tool to the next available worker, and worker executes the trade. And then it sends the results back to the server. And the server resumes the agent, picking up exactly where it left off. And if the compliance officer rejects the request, the server records the rejection with the reason. So you have the full audit trail: who approved or rejected, when, and why. And on top of all of this, Agentspan gives you a built-in dashboard at localhost 6767 where you can see the full workflow. Every LLM call, every tool call, timing, token counts, which tasks completed and which are waiting. So you don't need any extra setup or third-party observability tools. So that's the architecture. Now let me show you what this really looks like in practice. All right, so this is a very simple project. We have two main files over here, before.py and app.py. Before.py uses LangGraph to create the agent to showcase human in the loop scenario without using Agentspan. App.py contains our application for demonstrating human in the loop using Agentspan. First, let's look at before.py. So this code is creating a trading assistant that checks portfolio and execute trades, and the trade requires human approval via LangGraph's interrupt. At the top, we have some import statements. Then we are creating our chat OpenAI object. And then we have defined four nodes: check portfolio, plan trade, wait for approval, and execute trade. And this approval is blocking the input call. The process sits there waiting for someone to type yes or no in the terminal. Let's quickly execute it and see it in action. In the terminal, I'll run python before.py. So there are multiple steps involved. Step 1 is check portfolio. Step 2 is plan trade. So it is planning the trade to buy 100 shares of Nvidia at market price. Step 3 is waiting for human approval. And as you can see, it is waiting for us to type yes, no, or some reason. And this thread is kind of blocked right now. And let's say if the process crashes at this point of time, let me press Ctrl C and cancel it. Now that approval request is completely lost. If I run the same process again, it will start from step 1. It will again check the portfolio, it will plan the trade, and it will again wait for the human approval. But the previous approval is kind of meaningless. So that's the problem. Now here's the same thing with Agentspan. So this is one file which contains a market scanner, an AI trading agent, and an approval dashboard. And all of them are running together. Now with Agentspan, there are two components involved. One, the process which will start as a result of running Python app.py. And the other component is Agentspan server itself. Now starting Agentspan is really easy. You just need to execute two simple commands. First is pip install Agentspan. Just copy it from here, open the terminal, paste and run. Next, in step 2, you need to set your OpenAI API key because now Agentspan is going to make the LLM calls. So you need to export OpenAI API key. I have already done that. Next step is starting the server. Just copy this command, go back, paste and run. And then you can access Agentspan on localhost 6767. Here you can see all the agents, your queue monitor, agent credentials, all the executions and their in-depth details. Now let's quickly go through this code. At the top, we have a couple of import statements. Then we are defining our server URL, which is localhost 6767. And then we have defined a couple of tools and definitions. So we are using @tool decorator, which means all of these tools will be registered on the Agentspan server when app.py is executed. So we have one tool for checking portfolio, another one to execute trade. Then we are defining our agent. Further down, we have marked a couple of data for sending notifications and some signals. Then this is where we have created our dashboard. So it contains all the HTML code. Let me minimize this. And now these are the REST APIs for approving the request or rejecting it. Now this is our main run_scanner function. And it contains three key methods. First is runtime.deploy. This uploads the agent definitions to Agentspan server. And this is done once in the beginning. Next is runtime.serve. This one starts the worker threads that pulls the Agentspan server for tool tasks. When the server needs check_portfolio executed, these workers pick it up, run the Python function, and send the results back. So it is non-blocking. So the scanner keeps running. And finally, we have runtime.start. This triggers a new execution. It posts to the server and gets back an execution ID in about 50 milliseconds. The LLM calls happen on the server and not in this Python process. And one more piece, a background thread that polls the execution status. When it detects is_waiting is true, we know that the agent hit the approval gate. We update the dashboard and send a notification. So that's the code. Now let's open a new terminal and execute python app.py. So we can access our dashboard at localhost 8000. Let's open it. And this is our dashboard. Right now, there are no pending approvals. And if we go back, we can see that our agent is working on the tasks. So it has found one opportunity. And if you go back to the dashboard, we can see that it is processing NVIDIA. So it found that price dropped by 8% and it should take an action. So this one is pushed to pending approvals. Similarly, it is now processing for Tesla. And in the logs, you can see it has sent a notification to compliance at the rate hedgefund.com. And it is also showing up that approval request here on the dashboard. So it has found these four opportunities and it is done with analysis and now it is waiting for approvals. Now let me open these side by side. And by the way, we can expand all of these full parameters and get the entire information. And if I click on approve trade, on the right hand side in the logs, we can see that it was approved and the trade has been executed. And now that request has been removed from this list. Now we have only three. In the history, we can see that the request for NVIDIA has been approved. At the same time, if we come to our Agentspan dashboard, we can see that we have three active workflows. Let's open all of these one by one and see what's going on. So in this one, the trading agent got triggered and then it made a call to LLM. Then it found that it should execute check portfolio tool. So it sent a request to our worker. Worker executed this function and sent back the results to Agentspan server. In the next cycle, it again made a LLM call and now it is waiting for human approval. And if we click on check portfolio, let's click on output and we can see that this particular execution is for Tesla. Here in our dashboard, we can see that Tesla is waiting for approval. So if we go back to our agent executions and open this completed one, we can see that this workflow is complete. It made a call to LLM, then it got the check portfolio tool executed. It was waiting for human and it executed the trade. And finally, this workflow is complete. And here you can see that this entire workflow was for NVIDIA. Let's reject the request for Tesla and see what happens. If we open this workflow, which was for Tesla, we can see that the human approval was rejected and that's why it is showing approved equal to false. Reason is rejected. And so it terminated the workflow. And you can see the same in our logs. This request was rejected by the compliance officer. And so this workflow is now complete. And now the amazing part is even if our Python process or worker goes down for any reason, when it comes back up, it will pick up from where it left before crashing. So no approvals or tool executions are lost. All right, now let's look at a couple of advanced patterns that are really important in production. So there are three patterns I want to talk about. So the first one is really useful. Instead of binary yes or no, you can send edited parameters back to the agent. So it can be captured as a feedback. If we go back to our example, so here we can give a reason. Let's say we want to buy only 20 shares. That feedback can be passed from here. And then on agent span side, agent can accordingly decide what needs to be done. Second, the human tool. Now this is the inverse of approval. Instead of human getting the agent can actually ask question to a human whenever it needs to. You can create a human underscore tool, give it a name, a description, and add it to your agent's tools list. When the agent needs more information mid execution, it can call this tool. It's the same durable pause with the same REST API and same dashboard. And third, guardrail escalation. If your agent's output fails a validation check, instead of just keep on retrying, it can actually pause for a human review. The human can approve the output, edit it, reject it, give some suggestions, all through the same approval infrastructure we just built. And the way you do it is you define the agent and you define a couple of guardrails. In the guardrails, you can define onFail equal to onFail.human. I have just covered three of the most interesting use cases, but there is a long list of examples that you can go through and pick whichever suits your requirement. You can find all the resources I used in this video in my free school community. You can find the link in the description. Let me know what do you think about Agentspan in the comments. And if you got something out of this, don't forget to like the video and subscribe the channel. If you want to see how to make your agentic pipelines crash proof, don't forget to watch this video. Thanks for watching and I'll see you in the next one.